All right, so this is the first of a many-part review series where we're looking at just some of the big stuff we've learned this school year. This time, we're focusing on exponential equations, which was the beginning of Unit 5, predominantly 5-1 to 5-3. First one, we are graphing an exponential equation. And if you guys remember, in order to do that, you do need to make one of those tables. In your table, you are going to center your x's at wherever your exponent is a 0. This graph is going left 4, so I would want to do a -4 for my middle points. And I would also then go 1 point each way, which would mean I'm using a -5, and I'm also going to use a -3. Once you have your x's set up, you're just going to type them in the calculator and get your y's out. So you would just evaluate these and see what you end up with here. If you plug in that -4, you actually get out a -4 as well. If you plug in a -3, you're going to get a +4. And then if you plug in a -5, it looks like you'll get out -5.6, I believe. So you're going to end up with 3 separate points right here, and we're just going to graph those. So I would go, and I'm just going to go by ones here. A lot of times you do have to go by 5s or 10s, but this graph has really small numbers, which works out good. I am going to graph -5, comma, -5.6, which would be like there-ish. I got -4, comma, -4. And then I have a -3, comma, +4. So you graph your points, and once you have those in place, don't forget to graph your asymptotes. Your asymptote is your horizontal tail to the graph. This picture is moving down 6. So we're going to send that asymptote to y equals -6. And then what's going to end up happening is we're going to go ahead and just use those 3 dots. The graph is going to go flat on the left-hand side. We're going to hit our dots, and we're going to go really steep on the other side. So we've got our picture right here. Asymptote is y equals -6. To finish this off, this one didn't just have an equal sign. It actually did a greater than or equal to. That means we need to do shading, and we will shade above our picture. So this whole region up here is going to be where we have our solution. Moving on to our second problem here, it's one of those compound interest questions, and it says compounded quarterly. It's not continuously. So this formula right here, PERT, is out. That's only for continuous. It's going to be our first one. And when I set this up, I start with $3,000. It's 1 plus, my rate is 1.65%. You got to move that decimal twice, which is 0.0165. Quarterly means 4 times a year, so I'm going to put a 4 for n. And I would do an exponent of 4 again, times 7. If you type this into the calculator, you'll get your final amount. Final amount on this one ends up being 3366.50, which would mean if you subtract that from your initial 3,000, that's going to be $366.50 in interest. So make sure you always answer the question. Last question here is asking about the y-intercept from both of these scenarios. The y-intercept is when x is a 0. So the second one is actually really simple. I can just plug in a 0 for x, and if you do your math on this, this is going to cancel. It's just a 1. You will get a y-intercept of 4 when you put that 0 in for x. This table here doesn't give you an equation to plug into, but we can work backwards on our table and figure out when the x is a 0. My pattern says we are multiplying by 3 each time. So if I want to go backwards in my table, I just have to divide by 3. So that would make this number right here a 2. And if I divide by 3 again, it's going to be a decimal actually. It's going to be a 0.6 repeating. You just work your pattern backwards. That would mean that my second graph with the intercept of 4 has the greater value than the 0.6 on my first one.